Hello everyone, this lesson is about central limit theorem, but before we answer the problems, let us first identify what is central limit theorem. The central limit theorem, or CLT, is a statistical theory that states that given a sufficiently large sample size from a population with a finite level of variance, the mean of all samples from the same population will be approximately equal to the mean of the population. Now, let us proceed in our three problems. Problem number 1. The average price of a watch is 5,000 pesos. With a sample of 25 people and a standard deviation of 2,250, what is the probability of sample mean less than 5,500? Now, let us identify the important value in this problem. First, the value of our new mu is 5,000 pesos. The sample mean, or the X bar, is 5,500 pesos. The end value of population is 25 and the standard deviation of 2,250 pesos. In this test, we will find out how many percentage is the probability of the sample mean is less than 5,500 pesos, and in order to guide us, we will write this. X bar is less than 5,500, but wait, there is a value already, right? Do you want to know how? Let's proceed into our solution. Now, let us all remember the formula X bar minus mu all over the standard deviation of square root of n. Now, let us convert it into our given in the problem. 5,500 minus 5,000 all over 2,250 over square root 25, and after we compute it, the final answer will be 1.11. From this point on, we will find 1.11 in our z table, and after that we will get the value of 0.8665. But wait, in order to get the percentage, we need to move the decimal 2 places to the right to make it 86.65%. Here is the graph of our problem number 1. So, now you know on how did we get 86.65. Let's move on into our next problem. Problem number 2. The average price of a watch is 5,000 pesos. With a sample of 25 people and a standard deviation of 2,250, what is the probability of the sample mean greater than 5,500? Let us identify the important value in this problem. First, the value of our mu is 5,000 pesos. The sample mean, or the X bar again, is 5,500 pesos. The end value, or population, is 25 and the standard deviation of 2,250. In this test, we will find out how many percentage is the probability if the sample mean is greater than 5,500 pesos. And in order to guide us, we will write this. X bar is greater than 5,500, but wait, there is a value alright. Because you already know how to do it, let us answer it together. Let's proceed in our solution. We will use the same given formula as the previous one. Formula X bar minus mu all over the standard deviation over square root of n. Now let us convert it in our given problem. 5,500 minus 5,000 all over 2,250 over square root of 25. After we compute, the final answer will be 1.11. 1.11 is equal to 86.65, right? But in this question, we are looking for greater than. Always remember that the percentage that can be found in the z-table are always to the left of the graph, but in this, we need the value to the right because it is a greater than. This type of problem, what we need to do is to subtract the value from 100 in this problem. It will be 100 minus 86.65 in the total of 13.35%, and that will be the value for the right side and the final answer. This is the graph of the second question. Now, you know how to get the value with the greater than. Let us proceed in our last question. Problem number 3. The average price of a watch is 5,000 pesos. With a sample of 25 people and a standard deviation of 2,250, what is the probability of the sample mean between 4,700 and 5,500? Now let us identify the most important value in this problem. First, the value of our mu is 5,000 pesos. The sample mean, or x bar, is 5,500 pesos. But wait, we have 2 x bar in this question and the other one is 4,700. The n follower population is 25, while the standard deviation of 2,250 pesos. In this one, we will write x bar in between the two values. Using the same formula as the other two, x bar minus mu all over standard deviation over square root of n. Now let us convert it into our given problem. 5,500 minus 5,000 all over 2,250 over square root of 25, and after we compute, final answer will be 1.11. But this is for the x bar right again. Now this will be to the second one. X bar minus mu all over standard deviation over square root of n. Now let us convert it into our given the problem. 4,700 minus 5,000 all over 2,250 over square root of 25, and after we compute, it will be, final answer will be negative 0.67. Let us get the value of negative 0.67 and 1.11 in the z-table, and it will be 25.14% and 86.65%. This question is asking between the two values and what we need to be subtract 86.65 by 25.14, and the answer will be 61.51%, and that will be the value between and our also final answer. This is the graph of the third question. I hope you learned something new and have a good day, everyone.
One score Z test 1. Welcome to the first lesson. Before we proceed, the process of the tutorial, we will be introducing the topic, reading and analysis the problem, jotting down the given, and the 6 steps process of solving. Good luck students. Let's continue. Lesson 1 is about the one score Z test. A Z-test is a statistical test used to determine whether two population means are different when the variances are known and the sample size is large. The test statistic is assumed to have a normal distribution, and distance parameters such as standard deviation should be known for an accurate Z-test to be performed. Ready for question 1? Alright. In the population, the average IQ is 100 with a standard deviation of 18. A team of scientists want to test a new medication to see if it has either a positive or negative effect of intelligence or no effect at all. A sample of 50 participants who have taken the medication has mean of 135. Did the medication affect intelligence using alpha equals 0.05? Got the question? Now, for us not to have difficulties, let's write down the important given data. The mu is equal 100. The sample size represented as x bar is equal to 135. The population represented as n is equal to 50. and the standard deviation, which is represented by cursive looking O as O equals to 18 with an alpha of 0.05. Can you still follow? Let's proceed with step 1. Step 1 will be written the null hypothesis, which is represented by HO. It is what's being asked in the question. Since it's not asking which is greater than or less than, we'll use the equal sign. Therefore, the mu is equal to 100. We as well have to find the HA, or the alternative hypothesis. It's the opposite of HO, so the mu would be not equal to 100. Step 2. Write down the alpha, which is 0.05, and identify if it's two-tailed or one-tailed test. Since it doesn't show any signs of which greater than or less than variable, we will consider it is a two-tailed test. Step 3. Using a z-table, find the equivalent of the standard deviation. Find the value of 0.05 from the two-tailed area and trace the column down to its value. Here, we find that its value is positive negative 0.96. Can you still follow? You can do it. Step 4. We start to compute using scientific calculators. Follow the formula z is equal to x bar minus mu over standard deviation divided by the equal root of n. Input the given data, and there we get 13.74. Did you get the same answer? Try again. Step 5. We draw a graph, the curve with 0 as our center. Since it's two-tailed, graph at both sides of the 0 positive negative 1.96 and shade both regions. Then, mark where you z-score 13.74 falls. We see that it is inside the shaded area, which therefore bring us back to step 1 to label the HO is reject and HA is accepted. Step 6. Lastly, we conclude since we accept HA, we can say that new medication affects the intelligence of a person. See how easy that was? Let's move to problem 2. 1 score Z test 2. Problem 2. A health researcher read that a 2,000-pound male can burn an average of 475 calories per hour playing basketball. 35 males were randomly selected, and the mean number of calories burned per hour playing squash was 500 with a standard deviation of 47 calories. Do squash playing burn more calories per hour than basketball players? Test with alpha equals 0.01. Jot down the given. Mu is equal to 475. Sample size are x equals to 500. Population n equals to 35. Standard deviation is equal to 47 and the alpha of 0.01. Step 1. Our HA would be what is asked. Therefore, it is represented as mu is greater than 475. HO then is the opposite, which would be mu is less than or equal to 475. Step 2. Write the alpha, which would be 0.01. Since the question said the keyword more, it is one-tailed test. Step 3. The value of 0.01 at the z-table from the one-tailed row following the 0.01 column would be 2.326. Step 4. Input the given data according to the formula, then compute. We then get 3.14. Step 5 is drawing the curve and graphing. Still 0 in the middle, and since 2.326 is found at the positive side. We graph it at the right of 0. Locate where 3.14 falls. And since it's inside the shaded area, we go back to step 1, label the HA is accept and HO is reject. Step 6. You're doing great. Now we conclude that since we accept HA, there is enough evidence that squash players burn more calories per hour than basketball players. One score Z test 3. We're down to our last example for this topic and you're doing great. Alright, here's question 3. 25 high school students completely a preparation program for talking BEA test. The mean of these scores is 550. We know that the population average for BEA scores at 525 with a standard deviation of 100. Are the students' BEA scores significantly greater than the population mean of 525 with a population standard deviation of 100? Alpha equals to 0.05. Jot down the given. I know you know the variable already by now. For step 1, try HA would be mean is greater than 525 since it's the what's asked for the questions. And the opposite HO is less than or equal to 525. Step 2, the alpha would be 0.05 and since we saw the keyboard greater than, we consider it as one-tailed. Step 3. Again, find the value of alpha at the C table and there we pinpoint that it's equal to 1.645. Let's compute for step 4. Input data. Check you put them right. Then we get 1.76. Step 5. Hooray, we're almost done. Graph the curve. 0 still at the middle. Since 1.645 is positive, we graph it at the right side then shade. Then see where our scores 1.76 falls and that you will be inside the reject area. Again, go back to step 1 and label that we accept HA and reject HO. Step 6. Conclude that since we accept HA, there is enough evidence that these students' BEA score significantly greater than a population mean of 525. Great job, students, for learning this lesson. Go on forward to the next.